Good morning. Today we are covering Algebra 2 Lesson 8.4 on rational functions, vertical asymptotes, and holes. And you've been dealing with rational expressions. And rational expressions basically are made from fractions. So, example of a rational expression would be y equals some numerator number over x, some numerator number with x in it, and some denominator number, okay? And so let's do an example. We could do x plus 3 divided by 2x minus 4. Now, if we were to graph that, it's going to kind of give an interesting result. And so what you're going to have to do, take your graphing calculator here, and you're going to have to put parentheses around your numerator and your denominator when you put it into the graphing calculator. And I constantly struggle with putting those parentheses in. But let's just show you how we do it. So we turn this silly thing on and we clear this. Here we go, and clear this. And we're going to type in the numerator parentheses x plus 3 and close the parentheses, and then we're going to divide that, so that makes our denominator parentheses 2x minus 4. And then you've got to be sure to close the parentheses. Again, I always screw that up. And you just hit graph. And when you do that, it's going to create this interesting L shape up on the upper quadrant and then down here. And in between it, you've got a space, a vertical space. So if you were to draw this as a, just sketch a graph out, and if we were doing this live, I would have you sketching the graph out. But here's your L here going this way, and here's your L going this way, and then the space in the middle is just kind of and I'm a little bit odd. This is a vertical line, and so we call that vertical line that's made up of this space. It's just hope. Funny word. asymptote. That's called the vertical asymptote, that space. Okay? So we're going to be working with this with more complex fractions, and they're going to be set as equations, so there will be rational functions. All right? And so the other thing I want you to be aware of that you're going to be looking at, not just the vertical asymptotes, but the holes, and we're certainly going to be looking at the y-intercept when we do this. Okay? Now, let's find out what all those things are about. Okay, so let's look at our first example. And so here you have a function that's composed of a fraction. So this is a rational function. And the first thing we want to do is we want to find the y-intercept. So to find the y-intercept, you're going to need to set x equal to 0. So I'm going to take this and I'm going to set f of x to f of 0. X is going to equal 0. And that's going to equal numerator, we've got a 0 for x, so 0 minus 8. And then in the denominator, these x's are going to become 0, so we have 2 times 0 squared minus 22 times 0 plus 48. And then we extend this all the way out. Let's just move the 0 minus 8 over. Okay, and so this is going to simplify, and it simplifies pretty fast. In the numerator, you have negative 8. And in the denominator, this is 2 times 0 squared is 0. Negative 22 times 0 is 0. So you're left with negative 8 over 48. And when you reduce that, you can, let's see, you can divide out an 8 from both the numerator and the denominator. So you're going to be left with negative 1 over 6. Okay? And so that number then is going to go up into this. So this is asking for the y-intercept. In the y-intercept, we set the x to 0. So this is just 0. And this is what the output is. This is the y that we were looking for. So it's going to go over here. And so you're going to put in negative 1 over 6. Okay? So we've just found the y-intercept. Now, we want to find the undefined x values. So to get the undefined x values, then things are undefined when the 0 is under the bar. So things are undefined when 0 is under the bar. Now, what do I mean by under the bar? In the denominator. So your denominator is going to equal 0. That's where you're going to find an undefined x value. All right, so how do we find that? So what we're going to do is we're going to take the denominators. This is the denominator up here. We're going to bring it down here. And so we're going to write 2x squared minus 22x plus 48 equals 0. So we're just going to factor the denominators. The first thing I want to do is take the GCF out of this, because I've got a GCF that looks like of 2. So I'm going to rewrite this as 2 times, and then I'm left with x squared in the first term, minus 11x in the second term, and then 48 divided by 2 is 24, so plus 24 in the third term, and that's going to equal 0. Now we want to double bubble factor, okay? So that means I've got a 2 over here, and then I've got double bubble. So x and x make x squared, and what times what equals 24? That when added together is negative 11. Well, 3 times 8 is 24, and 3 plus 8 is 11. So negative 8 and negative 3. Okay, and that equals 0, because we always set these to equal 0. And so I'm going to say set y to equal 0. And that's what we did here. All right, so now let's do that. So I've got a 2 here, so we'll say 2 equals 0. Well, does it? Well, no, it doesn't. So this goes away. Doesn't work. But I can say that x minus 8 could equal 0, and x minus 3 could equal 0. So this becomes x equals 8, and this becomes x equals 3. Okay, so now if I were to put these into a calculator, I would have to take this and put in the fraction, and if I do trace and I enter these x values, you're going to find something unusual happens. So let's just do that for a moment. And so let's turn this back on again. Let's clear. And we're going to enter this new equation, or fractional equivalence. So y equals, this becomes y equals, and then I'm going to put parentheses, and then x minus 8. X minus 8, close the parentheses, division sign, and then parentheses. Remember, you got it's easy to make a mistake. 2x, and then squared, minus 22x plus 48. And then we have to close the parentheses. Looks like I did that right. So, graph. And we get this interesting looking graph. Now here's the thing. If I let x equal 8, let's see what my y is going to be. So I'm going to click trace, click the trace button, and you'll notice x equals 0 right now, and y equals negative 0.1666667, which is actually the the decimal version of negative 1 over 6, because this is the y-intercept up here, right? And so when the y-intercept, the x is 0. So if you remember, y-intercept x is 0 and the y is negative 1/6. And so they show that right here graphically, okay? But let's set the x to equal 8. So I'm going to make x equal 8. So I just type in an 8. And now you'll see it says x equals 8. And then I think we just hit enter. What does y equal? Well, there's nothing there. It's just blank. Y equals blank because it's undefined. Let's try 3. So I'm going to say x equals 3. So I'm just going to type a 3 in there. Now my x is 3. And hit enter. Y equals just a blank. So what that's telling you is that the undefined x values, these are undefined x values because we don't have a solution for y. It's undefined. So we're going to write that up here. Just put a line here. And our solution would be, we have 8 and 3, and we'll put these in these little curly cues. These are our undefined x values. That's where there is no solution for y. Okay? All right, so undefined x values are these x values, and they're undefined because there's no solution for y. We found that out when we looked at it up here. Found there's no solution for y here. Okay? All right. Now, let's go to the next one. So, got another fractional or rational equation, and we want to find the y-intercept. Okay, so let's go ahead and set x to 0, because your y-intercept always occurs when your x is 0, right? So f of 0 would equal, well, I got 0 squared minus 0 minus 90. And that's divided by 10 times 0 squared plus 6 times 0. Well, we're left with negative 90 over 0. Ouch. That's undefined. This is undefined. So our y is undefined. So when you see this, obviously you can't put in any values up here. It's just undefined. And so with delta math, I believe what you do in this case is you just submit nothing. So in delta math, submit nothing. Okay. All right, so now we want to find undefined x values. Here we found out our y value was undefined, but now we're going to look for undefined x values. So to do that, set your denominator to equal 0. So here's our denominator. So we're going to type in 10x squared plus 6x and make that equal 0. That's what this is up here. Okay, we're just bringing it down. Now we can take the GCF, right? So GCF this, and so we've got, looks like we can take 2x out of this. So GCF is going to be 2x. And so I've got 2x times, now 2 goes into 10 5 times, x goes into x squared x times, and then 2x goes into 6x 3 times, and so that's what we're left with. Okay, so we can go ahead and take 2x, and we'll set 2x to equal 0. Divide by 2, we get x equals 0. Okay, so that's one solution. And then I have 5x plus 3 equals 0. Subtract 3 from both sides, I get 5x equals negative 3, and then divide by 5, I get x equals negative 3 over 5. Okay, so I have two solutions for x under this situation. So they would be 0 and negative 3 over 5. Now, by the way, when you go into Delta Math, it provides these curly cues for the undefined x values. You just pop in the answers with a comma in between. Okay? So there you go. Pretty simple. Let's move on. All right, so now they want us to factor and simplify to find wholes and vertical asymptotes. Okay, and so we already looked at vertical asymptotes to some degree in our previous problem, well, actually we didn't. We just looked at the y-intercepts and the x-intercepts. So let's look at wholes and vertical asymptotes. And wholes occur when we have a common factor top and bottom. So an example might be 3x over 3x, okay, which equals 1. You know, that tells you what you're getting there, okay? And so they call that a hole. And remember, you can't see holes. Vertical asymptotes, we talked about those when we did the very opening slide here. So you know at least what that is to start with, generally speaking. All right, so let's take and start the process. First, we need to factor. So we're going to factor this whole thing. So if you look at this, in the numerator, I've got a GCF of 2. So I'm going to factor this. This is f of x equals. And then I'm going to factor the numerator. Make this equal sign better. I hate it when I do that. 2 times x plus 7. Because you divide 2 into 2x and 2 into 14, you get 2 times x plus 7. And then we're going to divide up the denominator by factoring. So we're going to double bubble that. So I start out with this 3x, and so the only way you can divide that up, it's 3x squared, pardon me, is to take 3x in the first bubble and x in the second one. That multiplies up to 3x squared. And then we have this 14, and let's see, it's going to be positive, whatever we multiply together, added together is all positive. We could certainly do 14 times 1. We could also do 7 times 2 when we're factoring this. Let's try 7 times 2. So put the smaller number, the 2, into the first bubble and the 7 into the second bubble. And so let's then check this. Let's do the rainbow thing. So, this is it. Multiply this together and this together. So 3x times 7, that's 21x. And then 2 times x is 2x. And we add those together, we get 23x, which you can see here checks. So we know we did this correctly. All right. So now, here's the thing. You've got in the numerator and the denominator an x plus 7. And so that reduces to 1. That reduces to 1. That is what you call a whole. Okay? So because it's a whole, what you're going to do is you're going to leave it out. This is a whole. You leave out your wholes in your function, and you create a reduced. So a reduced function. In other words, without the whole. So the reduced function would be f of x equals, this stuff goes away, so I have in the numerator, I'm left with 2, and in the denominator, I'm left with 3x plus 2. So the whole dropped out, and this is what you're left with, okay? So now your new whole function, see what we can factor here. We got the 2 in the numerator, that's going to stay. Let's go to, this is the whole we're trying to do. So I'm going to want to do, let's go back here. I forgot one thing. The whole, its factor was x plus 7. So that whole factor simplifies to, x plus 7 equals 2. So x equals 0, pardon me. So x equals negative 7. So that's the whole factor. So since it's the whole factor, we're going to put it in here, negative 7. All right, and then this is what we're left with, the reduced fraction. So I'm going to put this negative 7 in here for for the x and f of x. So f of negative 7 equals 2 over 3 times negative 7 plus 2. And that's going to equal 2 over, what's 3 times negative 7? That's negative 21 plus 2, which equals 2 over negative 19. And that's what goes down here, because that's your output. Output y value. So 2 over negative 19. All right. So the whole, you get rid of it up here. You take its x value and you make it the x value for the whole, and the y value is found by plugging the whole input into your reduced function and finding the output. So it's a shortcut of sorts. Right? Okay, so now we want to find the vertical asymptote. So the vertical asymptote comes from the denominator. I'm going to just abbreviate denominator. The denominator of the reduced function that we just did above. So the denominator of the reduced function was this 3x plus 2. So I'm going to take 3x plus 2. I'm going to let that equal 0. And so let's figure out what x is. So we're going to subtract 2 from both sides. So 3x, this cancels. 3x is going to equal negative 2, and then we divide by 3, and we get x equals 2 over 3. All right? So you're going to type the whole thing into the denominator, and this will graph into a vertical line. So if you type, so that when they want this value, you type this fraction into delta math, and this will graph into a vertical line. So, if you were to graph it at x equals negative 2/3, here's 1, x is negative 1. So negative 2/3 is somewhere in here. Your vertical line is going to go this way. X equals negative 2/3. Bring that up so you can see it. Okay, I was off the page and I apologize for that. We're going to have to move these around a little bit. Okay. Okay, so now let's go to the next one and see if we can go a little bit faster. All right, so if you look at the numerator here, we got a GCF of 2. We can divide out of 2. So let's do that. So I have f of x equals 2 times x, I'm left with an x and a negative 10, right? Divided by, all right, now I'm going to factor, I've got to factor this into double bubble, 2x squared plus 9x minus 35. So I'm going to set up my double bubble. And again, this 2x squared, I can only multiply it into 2x times x. Now, what times what is going to equal negative 35? So I could take negative 35 and 1. I could do 1 and negative 35. I could do negative 7 and 5. I could do negative 5 and 7. And that's what we would want, negative 5 and 7. So I'm going to put negative 5 here and positive 7 here. Okay. All right. So now let's look for holes. Let's make this a little cleaner. So I get 2x minus 5 here. Okay. So I have no holes. So there's no holes. All right? Because there's no common factors. No common numerator over denominator. Okay? No common numerator over denominator. All right, so don't have to worry about holes there. Therefore, I'm not going to worry about it here. None. Leave empty in delta math. Don't submit, I think. All right, so vertical asymptote then, what are we going to do? It's the denominator of the reduced fraction. Well, we didn't reduce the fraction, so we're just going to do what is it, 2x, it's factored, we can use the factor for it, 2x minus 5, save us some time, times x plus 7 equals 0, right? So 2x minus 5 equals 0, and x plus 7 equals 0. We know with this one, x equals -2. So that's one vertical asymptote x value. And remember, vertical asymptotes, when you graph them, they create a line. So this is actually the line that we talked about over here. Now, let's move this up. And this one, 2x minus 5, we're going to add 5 to both sides. And so we're going to get 2x, this cancels, equals 5, and then divide by 2. And so we get x equals 5 over 2. So that's the other vertical asymptote. So again, if you were to, you type this into delta math, like you would over here, okay? You type this in, these two x values into delta math, you're going to get what would be a vertical line. But remember, they're spaces. The vertical asymptotes are spaces where you could, draw in your dashed vertical line, okay? So there's one here at 5/2, there's one here at -2. Okay, 2 vertical asymptotes. Over here you had 1 vertical asymptote. Here you have 2. Okay? All right, so let's move on. So in this case, we're going to go just start through the deal. Look at this. This is difference of squares. So we can easily factor that. And then this one here has a GCF of 2 if you look at it. So GCF is 2. So let's factor. F of x equals, and then difference of squares, this would be x plus 5, x minus 5, if you remember. Because 5 times -5 is -25. Okay? And then you got, you're going to factor out the GCF, so 2 times x plus 5. So you'll notice you got x plus 5 over x plus 5. So you got a whole, at x plus 5 equals 0, or x equals, which simplifies into x equals -5. So you have a whole at x equals -5. All right, so now you're going to take the reduced fraction. So the reduced fraction, or reduced function, I'm sorry, is what's left. So you've got f of x equals x minus 5 in the numerator and just 2 in the denominator. Okay? Now you're going to let negative 5, your whole, the whole, equal x. So f of negative 5 equals negative 5 minus 5 over 2. Well, that equals 0 over 2. Now here the 0 is in the numerator, so that's going to just be 0. So your y, so your whole output, which is y, is 0. So here it goes. Put a 0 there. And the x value, we said, this is the x value, goes down here. All right, so that's where the whole is. Now, so the vertical asymptote, as you know, comes from the denominator. And so the denominator up here, what's the denominator left? It's 2. So vertical asymptote is the denominator, and then it equals 0. So the denominator here is 2. So 2 equals 0. But wait. Two does not equal 0. Okay. So there is no vertical asymptote. Okay, to solve for. So you just leave that alone. Again, I believe you just leave it blank in Delta Math. Okay, but it may give you the option of saying no vertical asymptote. I don't know. All right, so let's do this next one. We've got, looks like we're going to have to factor the numerator and the denominator. So f of x is going to equal, and then we've got no way around this. We're just going to have to do a complicated double bubble. So I got 5x over here and x over here. Now 36. 36. We can take 36 times negative 1. We could take negative 36 times 1. I'm sorry, 36 times negative 1, pardon me. So this is, you've got to end up with negative, so you have to have positive negative, it looks like. No, it has to be both negative. They have to both be negative. Negative 36 times negative 31 gives positive 36. All right, so then let's try negative 9 times negative 4. That's going to equal positive 36. I think that's what's going to work. But it's negative 4 times negative 9. So let's try it. And then check the rainbow. So negative 4 and negative 9. And if we check the old rainbow here, we've got 5 times negative 9 is negative 45. 5x times negative 9 is negative 45x. Negative 4 times negative 4 times x is negative 4x. And that adds up to negative 49x. So that's what we want. Okay, that checks. Okay. So we know this works. Let's do the denominator. So the denominator looks like we've got a GCF here. So GCF, we want to GCF this. We can take out 2. So I've got 2 times x squared minus 9. Now this is difference of squares. So different squares, let's redo this now. F of x equals, numerator stays the same, 5x minus 4 times x minus 9. The denominator would be 2 times x plus 3 times x minus 3. Again, we have no holes. No holes. Okay? Because nothing in the numerator and the denominator matches that we can take out. It's because, so, okay. And that's because no common factors in numerator and denominator. Okay? All right. So, no hole. Well, gone. And so then vertical asymptote, though, we take, again, the denominator. This is the fully factored denominator, right here, actually. We don't have a reduced function like we did over here where we had a hole. So we're going to take, that's 2 times x plus 3 times x minus 3, and we're going to set it to equal 0. If you'll remember, we want to set it to equal 0 because we want to find that vertical asymptote if it exists. Okay, so this solution is 2 equals 0. Well, that's obviously not going to work. So nothing there. But then I've got x plus 3 equals 0, and x minus 3 equals 0. And here x becomes x equals negative 3. So there's one vertical line asymptote. And the other one, this becomes x plus 3 equals 0. So there are two vertical asymptotes. All right, so let's try to define that. Let's take a calculator and see what happens. So, let's see if I can see this up here. So I'm going to type in this original fraction. So I've got, let's turn this on, let's clear, clear. Okay, so let's go to y equals, and we're going to type in the equation, and it's a fractional equation. So I've got parentheses, 5x, and I'm going to square it, minus 49x, and then plus 36, and I close that parentheses. Then I use the division sign, and I put in parentheses, and then 2x squared minus 18, and I close the parentheses. Looks like I got it all right. So I'm going to graph this. Now, if I did this right, I should have two vertical asymptotes. Let's find out. Ooh, this is a kooky, crazy thing. Well, okay. So the whole idea is that you have a line somewhere in the middle here. So there should be a vertical asymptote at x equals negative 3. So let's go over to x equals negative 3. So it should be somewhere here. So we can figure that out with a trace. If I push trace and I put negative 3 in here for x, so I'm going to type negative 3 and hit enter. Oops, I did that wrong. Let me go back. I may have to go back and retype the whole thing again. I should have just hit graph. So clear. Let's see if it'll let me do it. Trace. Okay, and so I'm going to put in again negative 3. Okay, and then I think here. Nope, didn't want to do it that way. Hope I don't have to put this back in again. All right, trace negative 3. Should have just worked with enter. Well, in any event, for some reason it's not working at the moment. I'm going to clear that. But we did get a good picture that showed us, and we know that at negative 3 we can go all the way through, and then at x is positive 3. So here's 1, 2, 3. It's right here. It's right here. Be a vertical line. Okay. What you would have seen is that you would have not gotten a value for y when you had your x is negative 3 or x is 3. Hopefully we can show that in the last problem. Oh, this is the last problem. We're done. Fantastic. So that's basically it. If you go to Desmos, they have a dandy graphing calculator, and it can help you do this. Okay. All right, so we're done. I'm going to close this. Have a great day. Bye-bye now.